talking about slopes of parallel and perpendicular lines. And we've already talked about this a little bit. And we said that we could determine if two lines were parallel or if two lines were perpendicular by looking at what? What can we look at to determine if two lines are parallel or perpendicular? We covered it last week. Look at the slope, right? And so if they are parallel, what's true about their slopes? They're the same. If they're perpendicular, what's true about their slopes? Opposite reciprocals. What does it mean to be opposite? One's positive, one's negative, and what's a reciprocal? One's flipped of the other, right? So like 4 and 1/4 would actually be 4 and negative 1/4, or 2/3 and a negative 3/2, something like that. Okay. All right. So let's look at this first example here. And it says, Pilar and Jake begin climbing to the top of a 100-foot mountain at the same time along two different sets of steps at the same rate. The table shows their distances above ground level after a number of steps. Okay, so we have Pilar down here. It shows she is 1.5 feet above the ground. Okay, it shows Jake, he is 4.5 feet above the ground. Now, it says they're traveling to the top at the same rate. Okay, and it shows their distances after so many steps. Okay, how many feet does each student climb after 10 steps? It says they're traveling at the same rate. What could you look at to determine? If you look at Pilar's, okay, one step, she had gone to a height of 2. Now look where she started. 1.5, right? Okay. After 3 steps, she had gone to a height of 3. So what's happening every time? She's going up 1/2 foot, right? Okay, now it says they travel at the same rate. So at one step, he started out at 4.5. One step, he goes to 5. Is his the same? Yes. Okay. So, after 10 steps, if they're going 1/2 foot every time, how far would each of them travel? 5 feet, right? Okay, good. Will Pilar and Jake be at the same height after the same number of steps? Why not? They started at different places, right? She's at 1.5 feet above the ground. He's up higher at 4.5 feet. So no, they would not. Okay. What would you expect the graphs of each to look like given the answers to part A and B? It'd be parallel, right? They're traveling at the same rate, right? Even though one started up higher than the other. So they would be parallel to each other. Good. Okay, here's another one. A hill and a gondola line 20 feet above the ground that goes up the hill both have slopes of 1/2. What is the geometric relationship between the hill and the gondola line? They're parallel, right? They have the same slopes. Now, they have written in the equation of both of these lines. Now, we talked about how to write the equation of the line, right? And we said that lines that are parallel have the same slope. Well, the equation of the gondola line is y equals 1/2 x plus 20. This is like the first quadrant of your coordinate plane, okay? So the hill is starting here at the origin. Its equation is y equals 1/2 x because it goes through the origin, so the y-intercept is 0, right? The gondola line is 20 feet higher, okay? So it's crossing the y-axis at 20, so its equation is y equals 1/2 x plus 20. I can notice looking at both of these, even if they hadn't given me this information up here, I can look at the slopes. Since I put it in slope-intercept form, I can look at the slopes and say these lines are parallel to each other because they have the same slope. Okay, but it would be important to put it in slope-intercept form in order to determine that. Okay, suppose another line for a chairlift is placed at a constant distance c below the gondola line. Okay, is the new line going to be parallel to the hill? So we're going to take and we're going to put another line at a constant distance from that gondola line. Okay, is that line, if I do that, is it going to be parallel to the other two? Yeah, right, because it's a constant distance from the gondola line. Okay, good. All right, now, you're going to have some problems like this, where they have some lines graphed, and you have to determine, are these lines parallel or perpendicular, okay? And so we're looking at this line, K, and this line in. Okay, now at first glance, they almost look like they might be parallel to each other, okay? But you need to check it, all right? So the important thing to do would be to find two good points on the line. Here's a good point. Probably there's a good point, right? Okay. And you rise and run to get to the other point. So if I rose 1, 2, 3, 4, 5 up and went back 1, 2, 3, 4, what's the slope of that line? A negative 5/4, right? Okay, it's slanting to the left. Okay, and then if we looked at n, here's a good point, and there's a good point. So again, I need to rise and run. Rise 1, 2, 3, 4 up, and 3 to the left. What's that slope going to be? Negative 4/3, right? So are these lines parallel? No. Okay. So the answer would be no. They have different slopes. Just one's a little steeper than the other. Pretty close, but not quite. You can tell that if you extended N and K at some point down there in the bottom, they would cross over each other. Okay, same type of question. This time we want to determine if J and K are perpendicular. Okay, so here's J and here's K. Again, I want to find some good points. So we're looking at J, there's a good point, and there's a good point. So I want to rise 1, 2, 3 and run back 2. What's the slope of that line? Negative 3/2. And then here is K. Here's a good point. And the y-intercept. You can see where it crosses the y-axis. This one rises 2 and runs a positive 3. What's that slope? Positive 2/3. Okay. Are those perpendicular? Yes. Okay. J is perpendicular to K. Okay. Slopes are opposite reciprocals. Sometimes they say the product of their slopes is -1. If I took and multiplied 2/3 and -3/2, would I get a -1? That's another way to say it. Okay. All right. What is the equation of the line through point P that is parallel to L? Okay. So here's line L. It's even given you the equation for line L. We could have found it, but they've given it to us. Sometimes you will have to find it. Okay, here's the equation for line L, and we want the equation of the line that's parallel to this one that goes through that point. Okay, so what do we need to get from the line? The slope. So what's the slope of my line going to be? 1/2, right? Okay, and it's going to go through this point for 1. Yes.
Going through the whole equation, could you just go over one and up 1 and over 2 to find the answer?
You could. I don't recommend that though. I mean, you could in a pinch if you couldn't remember how to do it, but I would definitely recommend knowing how to use that equation. It's going to save you some time. Okay. And again, we don't all graph beautifully. I mean, you should see some of the stuff that I see out there. And what ends up happening is they do it, but it's so sloppy they can't see where it crosses. So, okay. So we're going to do y minus y1 equals m times x minus x1. And I'm going to plug everything in. So I get y minus 1 equals 1/2 x minus 4. And I'm going to distribute the 1/2. And you end up with 1/2 x minus 2. Add 1 to both sides, and you get 1/2 x minus 1. All right, now, in my next problem, it says, what is the equation of the line through P that's perpendicular to L? Okay, so I'm going to use this same line, but this time I want the line that goes through that point so that it's perpendicular to this one. What do I need to do differently? My slope is not going to be 1/2, right? It's going to be -2. So this time I'm going to do a slope of -2 and going through that same point for 1. Okay? So I'm going to do y minus 1 equals -2 times x minus 4. And I'm going to distribute the -2. Okay? and then I'm going to add 1 to both sides. So I get y equals negative 2x plus 9. So this is the line that's parallel, and this is the line that's perpendicular. Okay, I've changed the wording from your paper so it looks a little bit differently. This one probably looks the same right here. This one I changed, and probably this up here. Okay, what are the equation of the lines parallel or perpendicular to the given line passing through point T? Okay, so this is my line, and I want it to be parallel so that it passes through this point T. What do I need to get from my line? Same what? The same slope, right? What is the slope of this one? Negative 3. So if my line is going to be parallel, I'm going to use that same slope, and it's going to go through that point, right? So we're going to do just like what we did up here, right? So we're going to do y minus 1 equals negative 3 times x minus 3. Distribute the negative 3, so I get negative 3x plus 9, and then add 1 to both sides. Questions on that? No? Okay. This time, last one, it's going to go through this line. It's going to go through that, or yeah, it's going to be perpendicular to this line and going through that point. Okay? Now, these happen to be 2 points that lie on the line. I don't have the equation of the line. So what do I need to do here? How's this going to be different? I need to find the slope, right? I need to find the slope of this line, but then my line is going to be perpendicular to it, so I'm going to have to get the opposite reciprocal, right? Okay, so I want to find the slope of this one, and so that would be 3 minus a negative 1 over 1 minus a negative 7. 3 plus 1, 1 plus 7. It ends up being 4/8, and that gives me a slope of 1/2, right? But my line's perpendicular, so my slope is now going to be what? Negative 2, okay, goes through the point 12, negative 2. So again, I plug it into my point slope form and then rearrange it and put it into slope intercept. So that's going to be y minus a negative 2 equals negative 2 times the quantity x minus 12. And I'm going to distribute the negative 2. So negative 2x plus 24. Subtract 2 from both sides. And there's my equation perpendicular to a given line. All right, questions? Okay, so we went through the whole lesson and nobody asked for the notes.